Hello, good morning student. This is your Jagadish Kumar Bandaru. Today we are going to discuss the most two important concepts in laws of motion. Laws of motion. So one concept, first concept is motion of blocks. Motion of blocks connected by massless strings. Second concept, we are going to discuss motion of blocks in contact. We will discuss one by one. So first we are going to discuss motion of the blocks connected by massless strings. Let us see. Here I am going to consider two blocks. Consider block A and block B. And its mass is M1, its mass is M2. This is I consider massless string. If it is a massless string, tension is same at all points throughout the string. That's why with what tension the string pulls the M1? T. With what tension the string pulls the M2? T. Why? Because tension is same at all points and tension is a pulling force. Tension is a pulling force. It always pulls the body. So what is the tension acting on the M1? T pulls it. So tension T pulls the M2. This is the tension T pulls the M1. All the tensions are same at all points throughout the string. Why? Because string is a massless. Here I am going to consider some force is acting here. Some force is acting here. So force pulls the system. So how to calculate acceleration of the system? How to calculate acceleration of the system? Otherwise, what is the how to calculate force? Whatever it may be. Suppose acceleration given and we need to calculate force. Suppose force given, how to calculate acceleration? Anything. Suppose what is the force here? Observe here, force. F is equal to. See, what is the net force acting on the system now? What is the net force acting on the system? These two tensions are equal and opposite, get cancel each other. Only this force is acting on the system. These two tensions are equal and opposite, get cancel each other. So only net force acting is this is only. That's why F is equal to total force acting on the system is only F. Even though tensions are acting, both are equal and opposite, get cancel each other. T equal and both are in opposite direction, get cancel each other. Only net force is F only. F is equal to, what is the total mass of the system? M1 plus M2. M1 plus M2. Why? Because string has no mass. We consider massless string. So M1 plus M2, negligible mass. So we are going to consider massless string. That's why total mass of the system M1 plus M2 into system acceleration A. Why? Because both are connected with a string, then both are moving with the same acceleration. That means total system moving with the same acceleration. That is A. Total system moving with the same acceleration A only. Total system moving with the same acceleration A, no doubt at all. That means M1 moving with A, M2 moving with A, the combination total system moving with A only. The acceleration A, that is only A. What is the F? Total force acting on the system. Why? Because these two are equal and opposite, get cancel each other, tensions. Second one, total mass of the system is M1 plus M2. String has no mass, M1 plus M2. And the total system moving with the same acceleration, that is A. So this is the F. From here, suppose they are going to give an F. How to calculate acceleration? This M1 plus M2 transpose to force side. Then force divided by M1 plus M2. This is the acceleration. This is the acceleration of the system. The next one, if I am going to consider how to calculate the tension. How to calculate the tension. Observe here, if I am going to calculate force pulls how many masses? M1 and M2. That's why I wrote m1 plus m2 and the system acceleration A. To calculate tension, the tension pulls how many blocks? The tension pulls how many blocks? Only one. This tension pulls only one block. What is that? M1. What is the acceleration of that M1 block? A. System acceleration and M1 acceleration, M2 acceleration, everything is same only. So A. That's all problem over. How to calculate tension? So this tension pulls how many masses? Only one mass, that is M1. So M1 into its acceleration A. That's all. Then T is equal to M1 into, how to calculate acceleration? By using this formula, calculate acceleration and substitute here. Otherwise, acceleration write down here directly. What is A? F by M1 plus M2. That's all. This is the tension formula. So that's all. Otherwise, calculate acceleration by using this formula and M1 into its acceleration will give the tension. That's all. So calculate acceleration from here and what is the tension in this thing? So tension T pulls only M1. So M1 into here, whatever the value we are going to get, substitute here, you are going to get the tension in the string. This is the one of the case. We will see the next case now. Second case. If I am going to consider this is the M1 and another block is M2, both are connected with a string, and we are going to pulling M1 now. Previously I pulled M2. I am going to apply the force on M2. Now I am going to apply the force on M1. In previous case I applied force on M2. Here I am going to apply the force on M1. Now what is the tension in the string? The tension in the string pulls M1 in this direction. The tension in the string pulls the M2 in this direction. This is the massless string. All the tensions are same. And what is the total force acting on the system now? These two tensions are magnitude equal and their directions are opposite. Tension magnitudes are equal and their directions are opposite. These tensions are get cancel each other. Then what is the total net force acting on the system? Only F. Only F. How to calculate the force? Total mass into its acceleration. What is the total mass? M1 plus M2. String has no mass. And what is the acceleration? A. What is this acceleration? System acceleration. System acceleration means M1 moving with the acceleration A, M2 moving with the acceleration A. That means total system is moving with the acceleration A only. Total system is moving with the acceleration A only. So total force acting on the system F. Total mass of the system M1 plus M2. String has no mass. And the total system acceleration is A. That's all. So F is equal to M1 plus M2 into A. How to calculate this acceleration? So if you know force and masses, transfer the M1 plus M2 force side. So force divided by M1 plus M2. Force by M1 plus M2. Acceleration is equal to force upon M1 plus M2. This is the acceleration. Suppose I need to calculate tension. Here F pulls two masses. I am going to consider M1 plus M2. Now the T pulls only one mass. This tension T pulls only one mass. So how to calculate tension? T pulls only one mass, that is M2, into its acceleration. That's all. This acceleration calculated from this formula. Substitute here. That M2 into its acceleration will give the tension. Why? Because tension force pulls M2 here. Then how to calculate tension? This tension pulls how many masses? Only one mass, that is M2. It is moving with acceleration A. That's why tension force we are going to get M2 into A. This acceleration we are going to get from this formula and substitute here. You are going to get the tension. So otherwise directly you require tension means. Tension pulls what? M2. How to calculate acceleration of the system? By using this formula. F by M1 plus M2. Sometimes in the objectives, this formula will give directly. Out of 4 options, so among the 4 options, one of the option is like this. Then we need to select directly. So if it is a problem, calculate the tension in this way. So first calculate the acceleration, and then how to calculate tension. Simply tension pulls M2 no. So tension is a force. It is pulls M2 only no. So M2 into A. That is the tension force. So M2 into A. That's all. That acceleration value substitute here, we are going to get the tension. That's all. Suppose the next case. I am going to consider 3 blocks here now. Connected by strings. Connected by strings. Now, its block mass is M1, this block mass is M2, this block mass is M3. All are massless strings. So that's why if I am going to consider force is acting in this direction like this, here force is acting like this. So what is the tension in the string? With what tension string pulls the M1? With what tension string pulls the M1? I am going to consider T1. Why? Because one more string is also there. That's why in first string tension I am going to consider T1. In second string tension I am going to consider T2. What is the tension in the first string? T1. What is the tension in the second string? T2. T2. So with what tension the string pulls M1? T1. With what tension string pulls M2? T1. Why? Because same string. Here with what tension the string pulls the M2? T2. With what tension string pulls the M3? T2. So these are the situation. And after that, how to calculate acceleration or how to calculate force. I am going to write the force equation also here. Force means mass into acceleration. From the Newton's second law, we know that. So here what happened? These tensions equal and opposite. These two tensions are equal and opposite, and that means both magnitudes are equal, directions are opposite, get cancel each other. These two tensions magnitudes are equal, directions are opposite, get cancel each other. That means what is the total net force acting on the system? Only F itself. Only F itself. So F is equal to, what is the total mass of the system? M1 plus M2 plus M3. What is the total acceleration of the system? A. The total system moving with the same acceleration A, no doubt at all. That means block A moving with acceleration A only, block B moving with acceleration A only, and the third block also, block C also moving with the acceleration only. This is the block A, this is the block B, this is the block C. Block A moving with acceleration A, block B moving with acceleration A, block C moving with acceleration A, total system is moving with acceleration A because all are connected with a string. Now what is the net force acting on the system? Only F. Why? Because these two tensions are equal and opposite, get cancel each other. These two tensions are equal and opposite, get cancel each other. Only one force itself, F, acting on the system. Now what is the total mass of the system? Now M1 plus M2 plus M3. Why? Because strings has no mass. Massless strings. Total system moving with acceleration A. That's all. By using this formula, one can calculate force if you know the masses and acceleration of the system. Otherwise, you need to calculate acceleration. Means acceleration is equal to transpose the M1 plus M2 plus M3, the force side. Then we are going to get the formula for acceleration F upon M1 plus M2 plus M3. That's all. Suppose you want to calculate tension T1. You want to calculate tension T1. Observe here. T1 pulls how many masses? So here F pulls, suppose here F pulling 3 masses, M1 plus M2 plus M3. We wrote. Why? Because F is pulling 3 masses. 1, 2, 3. M1 plus M2 plus M3 I wrote. But T1, to calculate T1 pulls how many masses? T1 pulls how many masses? So the T1 pulls only 1 mass. That is, T1 is pulling only 1 mass. That is M1. That's why M1 into its acceleration A. Problem over. That is the tension. So calculate the acceleration by using this formula. Why? Because all are moving with the same acceleration. Then calculate the acceleration by using this formula and substitute here. You are going to get the tension T1 simply. Sometimes in the options, you will give substitute this formula here. At the time, we need to remember that formula also. That is T1 is equal to M1 into what is A here? F upon M1 plus M2 plus M3. That's all. This is the formula. Directly we can calculate tension T1. How to calculate tension T2 now? Observe here. See, if force pulls the three masses, to calculate force, I consider three masses, M1 plus M2 plus M3. Why? Because force F pulling three masses. To calculate tension T1, I am going to using only M1 only. Why? Because tension T1 pulls only one mass M1 and its acceleration A. Mass into acceleration will give the tension force. That is tension. Tension is also force. That is according to Newton's second law. F is equal to MA formula only I wrote here. The next one, tension T2. How to calculate tension T2? So tension T2 pulls how many masses? Let us see. Tension T2 pulling two masses. Observe here. Tension T2 pulling two masses. 1 and 2. Why? Because while pulling this one, these tensions two equal and opposite get cancel each other. Then what is the total tension? What is the total force acting on this system M1 and M2? Only T2. Observe here. T2 is pulling. So observe here. I need to calculate T2. T2 pulling two masses M1 and M2. So T2 pulling M1 and M2. That's why T2 means what? T2 pulling two masses, that is M1 plus M2 into acceleration. Each and everything moving with the same acceleration A, system moving with the same acceleration A, the combined mass M1 and M2 also moving with the same acceleration A only, no doubt at all. Then this is the formula to calculate tension. Take the M1, M2 values and take the acceleration value from this formula and calculate the tension. Problem is over. So if you want the formula for tension T2 is equal to, this is what? M1 plus M2 into, I need to write the acceleration. Already we have the acceleration of F upon M1 plus M2 plus M3. That's all. By using this formula, one can calculate tension T2 also. That's all. Next system we are going to consider. Fourth one. Suppose this is the block A of mass M1, block B of mass M2, block C of mass M3. Just consider. Now force is pulls the M1. In previous concept we discussed. Force pulls the M3. We are going to apply the force on the M3 side. Here the force we are going to consider on M1 side. Concept is same only. Here how to calculate force if suppose E is given acceleration in the problem. So M1, M2 and M3 all are connected with the strings, massless strings of course. All are moving with the same acceleration in the direction of force. All are moving with the same acceleration. Then block M1 moving with acceleration EA, M2 moving with acceleration EA, M3 moving with acceleration EA, no doubt at all. All are connected with the string, all are moving with the same acceleration. Then how to calculate a force? Here I am going to consider M1. This is the string. The string pulls the M1 with tension T1. The string pulls the M2 with a tension T1. Why? Because in this string I am going to consider tension T1. In this string I am going to consider tension T2. At the time this string pulls the M2 with a tension T2. The same string pulls the M3 with a tension T2. So tension is a pulling force, always pulls the body. Now how to calculate a force? So these two tensions are equal and opposite, get cancel each other. These two tensions are equal and opposite, get cancel each other. What is the total net force acting on the system? Only F. F is equal to, how to calculate? This force pulls the three masses. So that's why M1 plus M2 plus M3 into the system moving with acceleration A. By using this formula, one can calculate force. So how to calculate acceleration? A is equal to force upon the total mass. The total mass. Both are equivalent only. Both are equivalent only. The next one, how to calculate the tension T1? Observe, tension T1. So tension T1. Tension T1. This is the tension T1. Tension T1 pulls M2 and M3 bodies. Tension T1 pulls M2 and M3 body. These two tensions are equal and opposite, cancel each other. Then tension T1 pulls only two masses M2 and M3. Why? Because this is the massless thing, and these two tensions are equal and opposite, cancel each other. So tension T1 now pulls only two blocks, one is M2 and M3. So that's why, what is the tension? So the masses pulled by the tension T1, 1 and 2, that is M2 plus M3 masses. And with what acceleration? M2 and M3 system moving. Total system moving with acceleration A. Each and every body moving with acceleration A. M2 plus M3 also combiningly moving with acceleration A only. No doubt at all. A. That's all. So substitute the M2 and M3 value, acceleration calculate from here and substitute here, you are going to get the result. Suppose you require tension formula, then T1 is equal to M2 plus M3 times, so acceleration formula substitute here. What is acceleration? Force upon total mass, sum of the three masses, M1 plus M2 plus M3. That's all. That's all. Now how to calculate tension T2? Tension T2. Tension T2 pulls only one mass, that is M3. Tension T2 pulls only one mass, that is M2. M3. Tension T2 pulls only one mass, that is M3. So M3 into its acceleration A. That's why by using this formula one can calculate tension. But what is the formula for tension T2? M3 into, what is A here? F by M1 plus M2 plus M3. This is the tension T2. So calculate acceleration here, M3 into that acceleration value substitute here, you are going to get the tension. If you are going to substitute in this formula, the same value only you are going to get. M3 value, F value, M1, M2, M3 value, substitute directly also. Whatever the value we are going to get here, the same value you are going to get by using this formula also. That's all. These are the simple tricks to solve the accelerations, forces, tensions in the case of motion of blocks connected by massless strings. Most important tricks, students. Remember, the next tricks we are going to see the concept related motion of the bodies in contact. Let us see, students. Second concept, motion of blocks in contact. So motion of blocks in contact. Suppose I am going to consider the first case. I am going to consider the two blocks are in contact. I am going to consider two blocks are in contact. Two blocks are in contact. This is the block A, this is the block B. Its mass is M1. Its mass is M1. Its mass is M2. I am going to consider. M2 I am going to consider. Here I am going to pushing with some force F. Here I am going to pushing with some force F from one side. From one side. At the time what will happen? So the both blocks move together with the same acceleration. Why? Because both are in contact. Both are in contact. Then both the blocks are moving with the same acceleration A. Then what is the acceleration of M1? A only. What is the acceleration of M2? A only. The total system acceleration A only. Why? Because both are in contact, moving with the same acceleration. Total system, individual masses also moving with the same acceleration A only. So here I am going to apply some force, pushing force. So some pushing force, some force is acting on the block, on the blocks. At the time what will happen? How to calculate this force? So any forces acting in the contact, definitely contact force will act. Contact force will act. There is a contact between the two blocks. That contact force will act. Observe, M1 applies some force on M2. That means M1 applies some force on M2. M1 applies some force on M2 means M2 experiences some force. That force I am going to consider small f. Small f. This small f I written inside the block B means block B experienced force. Remember, I am going to consider like that. My assumption is I am going to write inside the block B means that force is experienced by block B. Suppose if I am going to write inside the block A means that force is experienced by block A. That is, remember my student. Along with the direction I am going to mention. What is the magnitude of the force experienced by block B? F. In which direction? In the motion of direction I am going to consider. Why? Because M1 applies the force on M2 in the direction of motion only. In the direction of motion only. So what happened here? It applies the force. It applies the force. So this is the contact force magnitude and this is the direction it is experienced by block B applied by M1. According to Newton's third law, to every action there is an equal and opposite reaction. That's why the equal magnitude of the contact force applied by B on A also, that is how much force experienced by A, the equal magnitude but in opposite direction. So because of A, how much force experienced by B, magnitude F, and here my direction is I am going to consider somewhat east. We know that this direction is east means opposite direction is west. So the force experienced by the magnitude of the force experienced by B is F and in the direction of east. Then according to Newton's third law, to every action there is an equal and opposite reaction. That's why the force experienced by the magnitude of the force experienced by block A is also same F but in opposite direction, that is west. That means these two contacted forces I am going to represent it in this manner. Remember the thing we need to remember, if I am going to write the contact force inside the block B, that is experienced by block B. If I am going to write the contact force inside the block A means that is experienced by the block A. Those two forces are equal and opposite, of course. The next one. What is the total force acting on the system now? These two contact forces are equal and opposite. That's why get cancel each other. That's why only the capital F applied force itself, the total force acting on the system now, F is equal to. What is the total mass of the system now? M1 plus M2 into what is the acceleration of the system? A. That's all, problem over. Then what is A? Applied force by total mass. So I am going to repeat once again. What is the total force acting on the system? These two contact forces are equal and opposite, get cancel each other. So only applied force itself totally acting on the system. So applied force, total force acting on the system is equal to, what is the total mass of the system? M1 plus M2 times what is the acceleration of the system? A, that is in the direction of applied force. So this is the force formula. From this, how to calculate acceleration? F upon M1 plus M2. Both are equivalent only. The next one is how to calculate the contact force. Observe here, if I am going to consider this force, is I am going to consider like this. Then how many this force pushes how many masses? 2 masses, 1 and 2. Next, to calculate contact force, observe here, this force it pushes how many masses? Only 1 mass. This force pushes how many masses? Only 1 mass. This force pushes only 1 mass. This mass. So this force pushes only 1 mass. Observe here. Observe here. This force pushes only one mass. At the time, this force pushes only one mass means consider F is equal to, what is the mass pushed by this force? M2. With what acceleration it is moving? E. That's our problem over. You are going to calculate the contact force. You are going to calculate that contact force M2 into A. This A we are going to calculate by using this formula. Suppose the required formula for contact force means M2 into what is A? F by M1 plus M2. That's our problem over. That's our problem over. By using this formula, we can calculate contact force. How to calculate contact force? This force pushes only M2. So M2 into acceleration of the block. This acceleration we are going to calculate it from this formula. Substitute here. We are going to get the contact force. So that's all. And what is the formula for contact force? F is equal to M2 into acceleration. Already we know that. Substitute here. You are going to get the contact force formula. So the two formulas, what is the value you are going to get here? By using this also, we are going to get the same value. You can solve the problem in any way, your choice. Right. The next one. Next case, suppose I am going to consider this is the M1 block A and block B M2. This is the block A, this is the block B. I am going to assume M1 and M2. Now the force pushes the M2 side. I am going to push with a force F from the M2 side. Previously we are going to pushing the system from M1 side. Here now I am going to pushing the system from M2 side with the same force F. Suppose I am going to consider. Then how to solve the problems. Then how to solve the problems we will see. Here first of all I am going to consider this is the contact, no? Contact forces will act. Contact forces will act. Force applied by M2 on M1. Force applied by the M2 on M1. Initially force is applied by M2 on M1. Why? Because pushing force on M2, no? So it is moving in this direction with the acceleration A. System moving with acceleration A, I am going to assume. Then block A moving with acceleration A and block B also moving with the acceleration A only. Now, what is the contact force here? Observe here. M2 pushes, M2 applies contact force on A is F I am going to consider. At the same time, A also, M1 also applies, that is block A also applies same force on M2 in opposite direction. In opposite direction. Now this is the contact force experienced by block A. This is the contact force experienced by block B. Block B. Now what is the net force acting on the system? These two forces are equal and opposite, get cancel each other. Only applied force itself acting on the system totally. So F is equal to, what is the total mass of the system? M1 plus M2 into, what is the acceleration of the system? A. That's all. By using this formula, if you know M1 and M2 and the acceleration of the system, calculate force applied. Otherwise, by using this formula, if you know the force, calculate the acceleration by using this formula. Both are equivalent only. Acceleration is equal to F upon M1 plus M2. The next one, how to calculate contact force. How to calculate contact force. Observe here. This M1, by using this contact force, this contact force pushes only M1. Previously what I consider, these two forces are equal and opposite, get cancel each other. This force pushes M1 and M2 both masses. That's why I consider M1 and M2 and system moving with acceleration A. This is the I consider. Now I need to calculate contact force F. This contact force pushes how many masses? This contact force pushes how many masses? This contact force pushes only M1. This contact force pushes only M1. That means contact force is equal to, so this contact force pushes only M1. So M1 into that mass acceleration is A. That's all. This acceleration calculate from this formula and substitute here. You are going to get the contact force simply. That's all. Otherwise, if you require formula means M1 into, what is the A here? What is the A here? M1 into what is the A here? This is the A. F upon M1 plus M2. That's all. That's all. By using this formula, one can calculate contact force. The next one is, I'm going to consider motion of 3 blocks in contact. Motion of 3 blocks in contact. This is M1. This is M2. This is M3. So force is pushing from one side like this. M1 side I am going to assuming. So total system moving with the acceleration A. Now M1 moving with the acceleration A, M2 moving with the acceleration A, M3 also moving with the same acceleration A. Then what are the contact forces? There are 2 contacts. That's why first contact I am going to consider F1 contact force. In the second contact I am going to consider contact force is F2. So here I am going to consider small f1, small f2, small f1 and small f2 I am going to using for the contact force at the 2 contacts. In the first contact I am going to consider here, let us see M1 side. This is the first contact I am going to consider. So what is the force experienced by M2 because of M1? Why? Because F is applied, F is pushes from M1 side. Then what happened? M1 applies a contact force on M2. That is M2 experiences the contact force. That is I am going to consider F1. According to Newton's third law, to every action there is an equal and opposite reaction. That's why M2 also applies same contact force in opposite direction on the M1. So M1 also experiences the same contact force F1 but in opposite direction. Similarly, at the second contact, M2 applies some contact force on M3. Then M3 experiences a contact force F2. In the same time, according to Newton's third law, M3 also applies same contact force, equal contact force on M2 in opposite direction. Right. Now, these 2 contact, how to calculate the force on the system? If you know the acceleration and total masses. Observe here, these 2 contact forces, equal and opposite get cancel each other. These 2 contact forces, equal and opposite get cancel each other. Then what is the total force acting on the system? Only the applied force itself. That is the total force acting on the system. Now what is the total mass of the system? Simply M1 plus M2 plus M3 into total acceleration of the system is A. So that acceleration acting in the direction of applied force. The total acceleration of the system, net acceleration of the system. So whatever it may be, acceleration of the system simply A. That is I wrote here. So if you know the acceleration, transpose the M1 plus M2 plus M3 on F side. Then F is equal to M1 plus M2 plus M3. So if F is given, masses are given, then by using this formula, we can calculate acceleration of the system. That is only mass of the, what is the acceleration of M1? This is the formula. What is the acceleration of the M2? This is the formula. What is the acceleration of M3? This is the formula. What is the acceleration of the system? This is the formula. That means acceleration is same individually and combined system also. By using this formula only we need to calculate. The next one, contact force. How to calculate contact force F1? Observe here. So this contact force, suppose I am going to consider this force. This force pushes how many masses? 1, 2, 3. That's why I am going to consider 3 masses. But F1, this F1 pushes how many masses? This F1 pushes how many masses? Only 2 masses. 2 masses. Why? Because these 2 are contact forces acting, even though acting those at this contact, these 2 contact forces are equal and opposite, get cancel each other. These 2 contact forces are equal and opposite, get cancel each other. Then what is the total force acting to move these 2 blocks from this side, from at this contact? At this contact, what is the total force acting to move these 2 blocks? Means only F1. So here at this contact, F1 only acting to move these 2 blocks. Why? Because at this contact forces are equal and opposite. At second contact, get cancel each other. That's why only F1 contact force pushes the total system here now at this contact. So at this contact, F1 pushes the 2 blocks. That's why to calculate F1 pushes 2 masses. No, take those 2 masses, M2 plus M3. That is the masses pushed by the F1 mass, F1 force. M2 plus M3, that is the total mass pushed by the contact force F1 into acceleration of the system A. Individually consider, combinedly consider, or any two masses combinedly consider, acceleration won't be changed A only. So M2 plus M3 A. Why? Because all are moving with the same acceleration A only. That's why M2 plus M3 also moving with the same acceleration A only. This is the formula to calculate contact force F1. Write down M2, M3 values and acceleration value, calculate from here, substitute, you are going to get the result. Otherwise, what is the formula for M1, F1? Directly let us see. M2 plus M3 into A. What is A? F upon M1 plus M2 plus M3. That's all. Now how to calculate contact force F2? So contact force F2. So this contact force F2 pushes, this contact force F2 pushes only one mass, M3. This contact force M3 pushes only M3. I need to verify in the direction of motion only, in the direction of acceleration I need to verify. So this contact force pushes how many masses in the direction of acceleration? Only one mass, that is M3. This F2 pushes how many masses in the direction of acceleration? Only one mass, that is M3. So F2 pushes M3 only. That's why M3 into its acceleration A. That's all. So M3 value substitute, acceleration value take from here, and you are going to get the contact force F2 simply. Then what is the formula for F2? So M3 into A. What is A? F upon M1 plus M2 plus M3. If you are going to using this formula, directly you are going to get F2. Otherwise, M3 and calculate acceleration from here, substitute that acceleration value here, you are going to get F2. Remember, these two formulas, in these two situations, we are going to get the same value only. Whatever the value we are going to get here, the same value we are going to get by using that formula also. Right. The next one. The next situation, this is the fourth situation. Motion of blocks in contact. This is the fourth situation I am going to discuss. Consider the M1, M2, M3. Now the blocks are pushed from M3 side. In previous case, we consider blocks are pushed from M1 side. Now the blocks are pushed from M3 side. Here what happened? Two contacts. At first contact I am going to consider contact force F1. At second contact I am going to consider contact force is F2. Observe here what happened? The contact force in the direction of force M2 applies a contact force on M1 is F1. According to Newton's law, M1 also applies a contact force on M2 in opposite direction. These two forces are equal and opposite, of course. At the same time, M3 applies some contact force on M2. That is, I am going to consider F2. M2 applies equal and opposite contact force on M3. So this is the contact force experienced by M1. This is the contact force experienced by M2. And this is the contact force experienced by M2. This is the contact force experienced by M3. This is the situation. At first contact, force is applied in this direction. Force pushes the blocks in this direction. At the time, M2 pushes the M1 with the F1 force, with the F1 contact force. That's why M1 experiences contact force F1. At the same time, according to Newton's law, M1 also applied the equal and opposite force on M2. That's why F1 magnitude equal opposite direction. So that's why what is the force experienced by M2 because of first contact F1. Similarly, M3 pushes with contact force F2. That means M3 applies a contact force F2 on M2. That means M2 experiences F2 contact force. According to Newton's third law, M2 also applies equal and opposite contact force on M3. That's why this F2 is the contact force experienced by the M3. Right. What is the total force acting on the system? These two forces are equal and opposite, get cancel each other. These two forces are equal and opposite, get cancel each other. Now the total force acting on the system is net force itself F, which is equal to total mass of the system. I am going to consider M1 plus M2 plus M3. So total blocks are moving with the same acceleration A. That acceleration is in the direction of force. Now this is also moving with acceleration A. This is also moving with acceleration A. This is also moving with acceleration A. Now, force is equal to mass into acceleration of the system. That's all. By using this formula, we can calculate applied force on the system provided M1, M2, M3 values and acceleration of the system. Suppose you need to calculate acceleration of the system. So, force upon M1 plus M2 plus M3. These three are equivalent only. Here, if you know acceleration masses, calculate force. If you know the force and masses, calculate the acceleration. That's all. Both are equivalent only. Now, I am going to calculate it. Contact force F1 now. So F1 here, observe here F1 pushes only one mass. Here capital F pushes three masses. That's why I'm going to consider three masses. But here F1 pushes, observe here, this is the F1. It pushes only one mass, that is M1. That's why M1 into its acceleration A. Its acceleration A. So M1 into its acceleration A. M1 into its acceleration A. So write down M1 value and acceleration value directly take from this formula. You are going to get the result. Suppose the required formula means F1 is equal to what? M1 into what is A? This is A. F by M1 plus M2 plus M3. That's all. Suppose you want to calculate F2. How to calculate? Observe here. At the second contact, you need to observe in the direction of force, F2 I need to consider. Here also I consider this F1. In the direction of force, F1 I need to consider. That F1 pushes how many masses I need to consider. That is the most important logic you need to remember. This is the trick to solve the problem in less than 30 seconds to save the time in NEET and IITs. Observe. If I am going to consider this force, how many masses are pushed by this force? 1, 2, 3. That's why I wrote here. If I am going to consider F1 at the first contact, I need to consider F1 in the direction of applied force. That is the most important thing. In the first contact, I need to consider F1 in the direction of applied force. In the direction of applied force, this is the F1. This F1 pushes how many masses? Only M1. That is why M1 into its acceleration. So M1, take the value and acceleration, calculate from this formula, substitute, you are going to get the F1 simply. Otherwise, direct formula, write down M1 into what is acceleration? F by M1 plus M2 plus M3. Whatever the value you are going to get by direct formula also, we are going to get the same value. That's all. F2, how to calculate F2? F2 means go for the second contact. At the second contact, in the direction of force, what is the F2 consider? In the direction of force, consider the F2. To calculate F2, go for the second contact. In the direction of force, what F2 is acting, that F2 consider. In the direction of force, which F2? Why? Because at the contact 2, we have the two F2s. Which F2 I need to consider? In the direction of force, which contact force is acting? Observe that contact force. In the direction of force, this contact force is acting. This contact force pushes how many masses? These two masses. At the time these two contact forces are equal and opposite, get cancel each other. At the time F2 pushes two masses M1 and M2. F2 pushes two masses M1 and M2. That's why I am going to take in the masses are pushed by F2 is only two masses, that is M1 and M2. M1 plus M2. What is the acceleration of the combined mass of M1 and M2? Same acceleration M only. So take the M1 and M2 values and acceleration value substitute here. You are going to take the acceleration from here. Calculate acceleration by using this formula, substitute here and take the M1 and M2 values. M1 and M2 values from the figure and take the from the figure or from the given data, of course, and take the acceleration from this formula. Calculate acceleration from this formula, substitute here, you are going to get the contact force F2. Otherwise, direct formula, what is contact force? F2 m1 plus m2, m1 plus m2 into acceleration. What is the acceleration formula? F upon m1 plus m2 plus m3. By using this formula also we are going to get the same result. Whatever the result we are going to get from here, the same result we are going to get from here also. So take the m1 plus m2. I am going to repeat once again how to calculate F2. So in the direction of force, this contact force F2 is acting. The contact force F2 pushes two masses. Why? Because these two forces are F1 and F2 equal and opposite, get cancel each other. So F2 pushes two masses m1 plus m2. F2 pushes two masses m1 and m2. Take the masses m1 plus m2, total mass pushed by F2 into its acceleration. How to calculate this acceleration? By using this formula. Why? Because system acceleration and individual accelerations and the combined any two masses acceleration, everything is same only. That's why A is equal to F by m1 plus m2 plus m3. By using this formula, calculate acceleration, substitute here, you are going to get the F2. Otherwise, direct formula, go for direct formula. F2 is equal to m1 plus m2 into what is acceleration? F upon m1 plus m2 plus m3. By using this formula, directly we are going to get contact force. Remember, these two formulas will give the same result. Whatever the value we are going to get, whatever the value for F2 we are going to get here, the same value we are going to get by using that formula also. Okay, my dear student, these are the very important and simple tricks to solve the problems in NEET and IIT to save the time. So, this is the simplest way. And we will continue in new concepts in next class. Thank you, my dear students.